This illustrates the use of an app to estimate the frequency response numerical figures from the data shown previously. The app first asks to select the data folder, then opens all the files of CSV format, which is the recommended format to save data from the AD to. Select one file. If all the data files listed are relevant, select Import All. Wait while the app is importing the files, which may take several seconds, then close all the data import windows. Then click Run. It may take many seconds to minutes to run the calculation, and the outcome are two files. One file shows the Bode plot, which shows the decrease of gain versus frequency, and the phase plot showing a change from pi phase difference to only pi over 2 at higher frequencies. The left-hand side is the conventional 2D Nyquist plot. The 3D Nyquist on the right uses the white arrow axis for frequency, and one can see the large gain with pi phase shift at low frequency, which turns into vanishing gain and pi over 2 at high frequency. A table displays the estimates of various quantities from the data. The second output file is simply a record of calculation output from each data file. A side note about the app. It calculates directly on the signal and does not use any of AD2 metadata saved in the file, except for the scales and units of time and voltages. Hence, as long as the digital data and the unit scales are correct, it is impervious to other errors. Frequencies. Calculated with Fourier transform. The frequency of each signal is calculated on its own. For high precision estimation of the frequency, it is necessary to collect signal data with enough number of periods, such as from 32 to 512, with the number of data points up to about 8,200, which is the buffer length of AD2 scopes. Hence, it is fine if the signal graph looks very dense with too many periods. If the relative frequency difference between the two signals is more than 1.4%, it won't calculate the relative phase. Amplitude. Calculated with root mean square. Then, the ratio of the two signal amplitudes is converted to dB. The DC levels of the signals are given for reference and sanity check. The relative phase of signal 2 versus signal 1 is calculated using quadrature.